Hello everyone, welcome to SciSoft Academy. Here we are empowering the education through digital content. This is me Mallikarjunan and today we are going to see the basics of pulsed radar system. So without further delay, let's get started. So these are all our today's session outlines. So first we are going to see the basics of pulsed radar systems, then we'll see the block diagram of it, then we'll move ahead with the working principles, then we'll see how to determine the range of the specific target. So now let's start with the basics of pulsed radar system. So we are going to see the basics of pulsed radar system. So in pulsed radar system, the very basic concept is we will be having a continuous wave generator, which is going to create a pulse wave for us in continuous manner. So all those continuous pulses are going to be transmitted in the atmosphere. The transmitted pulses are going to get reflected by the target. Based on the received pulse duration, we are going to calculate the range of the specific target. So this is the very basic information of this pulse radar system. Now we will move ahead with the block diagram of the pulse radar system. So this is the basic block diagram of pulse radar system, where we have two sections, one for transmitter and one for receiver. And if you see, the radar display is going to be a common section where from transmitter also it will get connected, and for receiver also it will be connected. And the workflow starts from the triggering source. The triggering source is going to generate a pulse wave for us. So continuous pulses is going to be generated, and the continuous wave generator is going to generate us the carrier wave. Let's take a sine wave or cosine wave. So this the pulses generated by the trigger source and the continuous wave generated by this continuous wave generator are going to be mixed, and this kind of pulses are going to be produced by the pulse modulator. And after that, the output is going to given to the output tube for modification. Usually the output tube is going to be gun oscillator or tramp-band amplifier or impact amplifier. So from there we are going to give the signal to duplexer for transmission into the atmosphere. So I hope the transmitter section is clear now. Now we will move ahead with the received section. So when we come to receive section, when we receive any transmitted pulse back, so we are going to receive it in the duplexer section first. So that duplexer section is going to give that received pulse to low noise amplifier. The low noise amplifier is going to minimize the noise and will help us to increase the received signal frequency. So after low noise amplifier, we will receive the received pulse frequency. So that received frequency is going to be given to the mixer. Mixer will actually process that received signal, and it is going to generate the intermediate frequency for us. So post that, this intermediate frequency is going to get amplified. So this intermediate frequency helps us to detect the range of the target which is entered into the atmosphere. So this is a very basic block diagram of pulse radar system. So now let's move ahead with the working principle of it. So as we have already seen from the block diagram, we will be having a continuous wave transmitter in the first section, where the pulse radar system is going to generate continuous pulses in the atmosphere. So whenever a target entered into the atmosphere, the transmitted pulses are going to get reflected by the entered target. So that is the basic concept. And from here, the range is going to be R. Let's say if the distance between the antenna and the target is going to be R, then the total distance traveled by the pulse is going to be 2 times of R, because the signal has to travel from the antenna to the target, that is 1 times of R, and from there the signal is going to get reflected by the target. So from the target to antenna again. So that's why the total distance is going to be 2 times of R. So let's move ahead with a few equations to understand more about determining the range of the target. And let's assume that the transmitter pulse is given by the picture, and we are receiving the pulse after a duration. So let's assume that the time taken to receive the pulse is t, and we'll take the assumptions like velocity of the signal is going to be c, and the distance of the signal is going to be 2 times of r. So this we have already seen in the previous section, so how it becomes 2r. And now since we are assuming that the time required to receive the pulse back is going to be t, so based on this we already know the distance is going to be speed into time. So in our case we need the velocity, so velocity c is going to be the distance, total distance is 2r dividing by the time. So if you want to calculate the range of the target, then the range is r is going to be c into t dividing by t. So this is straightforward calculations. So thank you for watching this video, guys. So all the class notes with examples some solved are uploaded in the cloud, and we have shared the link in the description. Do let us know if you have any questions in the comment section. Thank you for watching this video. See you in the next one.